You learned in your Intro to Computers course that a computer is a digital device that operates on streams of high-low or on-off electronic voltage signals. You might remember that the computer data is measured in kilobytes, megabytes, or gigabytes, all of which are measurements of the number of bytes, with a byte comprised of 8 bits, and each bit is either a 0 or a 1. That 0 is the off signal and the 1 is the on signal. That's all the computer understands, zeros and ones. When I write a letter, the text of that letter and all the formatting information is saved in my drive as a sequence of zeros and ones. And all the images that we display on our monitors are all stored and displayed as a massive collection of zeros and ones. When I press a key on the keyboard in writing that letter, the keyboard is sending a specific sequence of zeros and ones for each character I type. In the back of your textbook, or if you do a search for ASCII character chart on the internet, you'll find a bunch of different ASCII tables. ASCII stands for the American Standard Code for Information Interchange. It was decided long ago about how characters will be represented in the computer world digitally. I mentioned computers are digital, they're binary. They only know zeros and ones. So how do we represent, say, a capital A as zeros and ones? Well, a capital A is a sequence of zeros and ones for 01000001. But if you look at this ASCII chart, we can see that a capital A is a 65. Now that 01000001 is the binary, but the decimal equivalent is 65. And we'll look at how to convert that here in just a minute. When we're working with ASCII codes, we don't work with the binary usually in programming. We work with the decimal value. That's 65. We might also work with hexadecimal, particularly when we're working with colors. So you'll see ASCII charts that show the binary, the decimal, the hexadecimal. There's also one called octal, which is a base 8. So binary is base 2, decimal number is a base 10, so we're used to working in. Hexadecimal is a base 16, and octal is a base 8. Let's dive a little bit deeper on this. I've created an application in Visual Basic that shows the binary values of a byte, and I can click on any of these values and change them. And then it shows me the decimal equivalent, the hexadecimal equivalent, and the resulting ASCII character of a standard font. So when I type a capital A, this is the sequence I'm getting as a binary value, but its decimal equivalent is 65. And that's the number we as programmers work with primarily in working with characters. Then there's an equivalent hexadecimal value, which is a base 16. That's the number we'll work with primarily with colors, and we'll look at that a little bit later in this video. And then here we see the character. Now let's talk about how we convert this. How do I get 65 out of this? Let's think about our second grade math, where we learned the number 527 has a ones digit of 7, a tens digit of 2, and a hundreds digit of 5. And it's the same as being 5 times 100 plus 2 times 10 plus 7 times 1. So here, in our binary value, we don't work with ones, tens, and hundreds. We work with ones, the number of twos, the number of fours, 8s, 16s, 32s, 64, and 128s. An easy way to remember that is this is a binary, whereas any digit in a decimal value can have a value from 0 to 9, 10 different values, base 10. Here we have a value of 0 or 1 in any one of these places. It's a base 2. And so we can start with the first one is the number ones, and then just double each time over to the left. So doubling 1 is 2, doubling 2 is 4, doubling 4 is 8, and so forth. If we had all ones, the max value is 255. And of course, if these are all zeros, our value is 0. So when I type a capital A, I'm getting a 64 plus a 1 is 65. If I type a capital B, I'm getting a 64 plus 2, which is 66. Here's the capital C. Now if I have a 32-bit turned on here, again I'm going to lowercase c, so it's 64 plus 32 plus 2 plus 1 is 99. Now the one thing to realize here is that the lowercase ASCII value, in this case the lowercase a, is 97. It's always 32 more than the uppercase. So uppercase is a lower decimal value, and that's important when we get to comparing strings. There's the lowercase b at 98, but the uppercase B is 66. 66 plus 32, 98. So that's how we can convert between the binary to the decimal. Well, what about this hexadecimal? Let's get a large number here. And 226 in this case has a hexadecimal equivalent of E2. Well, what's the E? Well, we said the base 10 has a value from 0 to 9 of any one of these digits. In a base 16 hexadecimal system, we have to go from 0 to 15. I created a little chart here. When we get beyond the 9, we start using letters. So A is 10, B is 11, C is 12, D is 13, E 14, and F 15. So here we have 14 16s, which is 224, plus a 2, 226. Here we have hexadecimal value of AA, which is 170. Now an A is 10. So 10 times 16 is 160, and 10 times 1 is 10. 160 plus 10 is 170. If these are all 1s, the 255 value is FF. That'll become important as we look at colors here in just a minute. And of course, if they're all 0s, our hexadecimal value is 0. What if I have a value of 81 and I want to convert that to the binary? We start with 128. This is sort of that modulus integer division that we can do. Start with our decimal value and divide by 128. Well, 128 doesn't go into that at all, so it's a 0. But 64 does go into 81 and leaves us a value of 17 remainder. So we can put a 1 for the 64. 32 won't go into the 17, so that's a 0, but 16 will. That's a 1. That leaves us 1 left over, and that's our 1 digit here. We can convert the other way by doing just some simple division and seeing if each bit will fit into our decimal value. Let's take a look at how this binary, decimal, and hexadecimal values play into working with RGB colors that we see on our monitor. A standard monitor these days is 1920 pixels wide by 1080 pixels high. That's a little over 2 million pixels total. And each pixel, of course, is a dot of color. Behind each pixel are 3 phosphors of red, green, and blue that are set to a value between 0 and 255. 255 being that they're fully on, and 0 that they're fully off. We can combine those values to create any one of 16.7 million colors. That's why they call this an RGB, or red, green, blue, 24-bit system. Let's unpack that a little bit more. The color of this swatch over here is defined by these red and green, blue sliders, and I can change that color by changing these sliders. Now let's pretend for a minute that we're in a room, and in the ceiling of the room we have red lights, green lights, and blue lights, and there are 3 dimmer switches over on the wall, and that's what these represent. So right now the red light is fully on, the green light is fully on, and the blue light is fully on, and when those are combined we get white light, and our room is flooded with white light. And of course, if we take those dimmers and we turn them all the way off, we have no light and the room is pitch black. If I have just the red on, we have red light, and it's like we're in a photography darkroom. If I add in the green light, red and green combined creates yellow, but if I add in the blue light without the green, we're getting magenta. So I can play with these sliders and get any one of 16.7 million different colors, and we see the representation here of the binary values. So this is why they call it a 24-bit RGB. There's 8 bits for red, 8 for green, 8 for blue, and then here's the hexadecimal values. Now we don't want to work with these binary numbers with a client who says, oh, my company's color is 010000, so forth. They're going to say, oh, my company's color is a hexadecimal 40cc71. We're going to work with that value when we're working with the client and making sure we're consistent with their brand of color. Now I can give you some examples here of color swatches. So a gray is always going to have red, green, and blue at the same level, but it could be at different levels. So this is a mid-gray. Everything is 128. Here's a light gray where everything is DC. We've seen red, we've seen green, we've seen blue, yellow, magenta, cyan. All those have settings at the max and low. Here's orange. A lot of red, fair amount of green, but no blue. light pink, just turning the green and blue down a little bit. Here is a brown. Everything's much lower because we're getting a darker color, less light, but there's still a lot more red than there's green or blue. Dark green, no red or blue, and the green is set at the mid-range. Light blue, kind of a gold color. Purple, a lot of blue, quite a bit of red, very little green. And then a teal, green and blue at the mid-level, no red. So that's how colors are comprised. There are about 140 named colors in Microsoft, and I provided a chart of those for you in our Canvas course site. You don't need to memorize any of those, of course, because when we use IntelliSense, such as LBL output.backcolor equals color dot, the IntelliSense will show us all those names, but it doesn't show us what those values are. So that's where this chart can come in handy. But as I said, there are 16.7 million different colors. How do we display any of those other colors for our back color? I want to work with the sky blue color. And we can see there's listed as FF87CEEB. Now notice that FF is in front of all of the colors here. That is the alpha channel, and FF means it's totally opaque. Back in my app, I set the sliders to give us that sky blue color of 87CEEB, and we can see the decimal values there that are equivalent to that is 135, 206, and 235. Now in Visual Basic, I can set any of those named colors simply by using color dot in the name of the color. So here we have LBL output.backcolor equals color dot sky blue. But what if this wasn't a named color? Well, we can use the from ARGB method as part of the color class, and I can say LBL output.backcolor equals color dot from ARGB. And then I can specify 4 things here. That alpha channel, which is going to be our 255. Now these are going to be in integers. So this is where I need to know what the red, green, and blue decimal equivalents are. So it would be 255 is alpha, red is 135, green is 206, and blue is 235. However, because the alpha is normally going to be 255, you can drop that off. So there's what we call an overloaded method in that I can specify just the red, green, blue values. Now, how do I find those decimal equivalents? Well, of course, we can take the red value of 87 and multiply the 8 by 16. That's going to give us 128, and add 7. That's 135. I can take the C of the CE green, and C, of course, is 12. 12 times 16 is 192, and add the 14 of E, E being 14. So 192 and 14 is 206. And then finally, for the blue channel, E being 14 times 16 is 224, plus the B is 11, so 224 plus 11 is 235. Now, some of the ways we can do this, I use Photoshop a lot, and in Photoshop we can click on our foreground color to bring up the color picker, and in the color picker I can then type in the hexadecimal value of the color I want to find, 87CEEB, and notice when I do that, it's going to give me the red, green, and blue values. Those are the values that I can use in that from ARGB method. And of course, you have to know there's going to be a website where we can type in our hexadecimal value. Look at how we use these ASCII values in displaying special characters. And it'll give us the RGB values of red, green, blue. So this is the website at w3schools.com. So that's another resource for you. It always seems strange to me that since we primarily work with hexadecimal color values, that the color class does not have a from hex method, just like it has a from ARGB method, that we have to use these red, green, blue decimal values. But there's a way to do this from a hexadecimal value, and that is there is a class called color translator that has a from HTML method, and in that HTML method we can specify a hexadecimal color. So to get this sky blue into my LBL output, I can specify LBL output.backcolor equals color transit.from HTML, and then the parentheses, the hashtag 87CEEB. We want to make sure we put the hashtag in front of our hexadecimal value because that says to VB that this is a hexadecimal value. Southmont Community College has a branding color that they use. It's an orange, and it's a very specific orange. And it is CF7F00. So if I want to use that in my application, I can use that color translator.from HTML. Probably the best way to do this, if I want to use it maybe in several locations, is to create a new color variable. So I can dim SMCC orange as a color, and I'm specifying it's a new color. That gives it a new instance of my class for this variable. And then I'm going to say that SMCC color equals color translator.from HTML, specify the hex, and then I can use that SMCC orange directly in my LBL.backColor statement. So that's how we work with colors in Visual Basic using the hexadecimal values and the decimal values. Remember, those are all represented by the binary. In the next video, we'll look at how to create special characters using the decimal values of our ASCII chart. However, there's also the character map app inside of Windows, and we can choose a font. Let's say we're working with Arial. It's basically our ASCII chart in a sense, and we can choose, here's like a capital A, and I can click on that and it shows me the hexadecimal value. So it's 0041. Now, we talk about ASCII values being 8-bit, but today we use Unicode fonts and Unicode characters that are 16-bit. All the ASCII characters are still the same value. There's nothing in that front-loaded byte, so it's 00. So those first two numbers are the first 8 bits, and the next one's the next 8 bits. So it's still going to be 41. In Visual Basic, we can use CHR with our ASCII value, or for our Unicode values, we can use CHRW. We'll look at that in the next video. But here's another way we can find what is the value of the different characters. So for example, here's my copyright symbol, and it is A9. Over here, it also shows the keystroke. I can type that directly into my code, holding down the Alt key and pressing 0169. So hopefully you have a little better understanding now of the binary system of computers and how that translates into decimal and hexadecimal, and how we can use those values in our coding. If you just jumped into this video, you can see all the videos from the Programming Practicum playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos I create, you can click my picture in the top right to subscribe to the channel.